Have you ever wished you had more time? What if I told you that time isn't as constant as we think? In fact, it can stretch and shrink, and this isn't science fiction, it's real proven physics. Welcome to the mind-bending world of time dilation. So, what exactly is time dilation? The idea comes from Albert Einstein's theory of relativity. It basically says that the faster you move through space, the slower you move through time. Imagine two twins. One stays on Earth, and the other blasts off in a super-fast spaceship, traveling close to the speed of light. When the spacefaring twin returns, they'll find they have aged less than their sibling who stayed behind. For the traveler, maybe only a few years have passed, but for the one on Earth, decades could have gone by. Weird, right? But this isn't just about spaceships. Time dilation happens to us every single day, just on a much smaller, unnoticeable scale. For example, GPS satellites orbit the Earth at high speeds. To give us accurate directions, their clocks have to be constantly adjusted to account for time dilation. Because they're moving so fast relative to us on the ground, their internal clocks actually run slightly slower. If scientists didn't correct for this, your GPS would be off by several miles every single day. So how does this work? Einstein realized that the speed of light in a vacuum is the ultimate speed limit of the universe. Nothing can go faster. He pictured space and time as a single interwoven fabric called space-time. Massive objects like planets and stars create curves or dips in this fabric. This curvature is what we feel as gravity. But motion also has an effect. As you speed up, your journey through space-time gets reallocated. More of your motion goes towards moving through space and less goes towards moving through time. Think of it like a budget. You have a fixed amount of speed through space-time. The faster you travel through space, the less speed is left for traveling through time. Now let's talk about the other type of time dilation, gravitational time dilation. This one says that time moves slower in stronger gravitational fields. So, time actually passes slightly slower for your feet than for your head because your feet are closer to Earth's center of gravity. Of course, the difference is incredibly tiny, but it's real. On a much larger scale, time on a massive planet like Jupiter runs slower than time on Earth. And near a black hole, where gravity is extreme, time can slow down dramatically. If you could hover near the edge of a black hole and then return, you might find that thousands of years have passed on Earth. You'd be a time traveler to the future. This might all sound like something out of a movie, but it has been experimentally verified countless times. In one famous experiment, scientists put hyper-accurate atomic clocks on airplanes and flew them around the world. When they compared them to identical clocks left on the ground, they found that the clocks on the planes had indeed ticked just a fraction of a second slower, exactly as Einstein's equations predicted. The implications of time dilation are staggering. It challenges our fundamental intuition about reality. Time is not a universal metronome ticking at the same rate for everyone. Your personal experience of time depends on your motion and your location in the universe. It means every one of us has our own personal clock, ticking at its own unique rate. So, the next time you're on a plane or even just climbing a flight of stairs, remember you're manipulating time, even if just by a little bit. The universe is far stranger and more wonderful than we can imagine. Thanks so much for exploring this fascinating topic with me. If you enjoyed this journey through space-time, don't forget to hit that like button and subscribe for more deep dives into the mysteries of our universe. See you next time.